In this lesson, we're going to do some basic mathematical operations, and I believe that, of course, we already know what these basic mathematical operations are. So here, we are going to understand and digest a lot of things about basic mathematical operations. And in this course, of course, we will be learning about how we do the mathematics using Python, because this is actually the very basic thing that we have to really know when we do data science. So apart from knowing the mathematical hardcore itself, we also need to understand and know the mathematical operations using Python. So we will start with the basic mathematical operations. And of course, we already know that we just use this addition and subtraction operators to do these two operations. So for example, we have 1 plus 1 becomes 2. And when we do the minus or subtraction, so we have 3 minus 1, then it becomes 2, of course. 1 minus 7, that would give us a negative 6. And negative 10 plus 3, that would give us negative 7. 1.1 minus 4, so we can also do the operations between the whole number and decimals. So 1 minus, or 1.1 minus 4, that becomes negative 2.9. So how about when we do the multiplication? So in multiplication, we just use this operation or operator. So you could say this is just an asterisk. So for example, we have 4 minus, or 4 times 3, or 4 multiplied by 3. This will give us, so it's still working. So this will give us, of course, 12. We can also do the multiplication between two decimals. So for example, we have 3.5 times 4.4. This will give us 15.4, and so on and so forth. So also, in division, we can use this operator, slash operator. 4 divided by 5, this will give us 0.8. And 4.4 divided by negative 2, this will give us negative 2.2. And sometimes, what we want to see is just the whole number. So we would like to remove the decimals. So what we would do is just we're going to use this floor division operator. So just having two slashes. So for example, we have 4.4 divided by, or divided by 3. This will give us 1. So this is already a whole number. And negative 3 divided by 2, this will give us, or negative 3 divided by 2, this will give us negative 2. So basically, when we divide this one, having decimal places, negative 3 divided by 2, that will give us 1.5. So automatically, using this one, we will be given a round-off value of the result, or of the quotient. So also, we could use the modulo operator if we would like to see the remainder. So the spelling is wrong here, so let me remove 1D. Right. Oops. So the remainder, right? So remainder. Okay. 4.4 divided by 3. This will give us this one, its value. So here, right, 4.4 divided by 3. So here we are shown with the remainders, or those value or digits in the decimal places. So here, negative 3 divided by 2. So the remainder is 1. So let's go back to this one first. I have a mistake. So this one, 1.4, is actually the remainder of this one. So because 4.4 divided by 3 is 1, so this one is the remainder. So also, another thing is that we can also calculate the powers of numbers excuse, using the exponential operator. So we're just going to have these two asterisks. So that means 2 raised to the power of 2. That will give us 4. And also, we can use the exponential symbol to calculate the powers less than 1. So for example, the square root of a number, n, can be expressed in n over 1/2, and the cube root as n to the power of 1 over 3. So this means that 16, or the square root of 16 with these two asterisks times 1/2, that will give us 4. So it means to say that the square root of 16. So Python will also evaluate the expression following the standard PEMDAS. So this is actually a very basic rule in mathematics. When we do have a series of operations, the question would be, what are we going to do? So which operation we're going to do first, the second, the third, and so forth. So with this PEMDAS, which means parenthesis, then we're going to do the exponents, if we could see. Then we will have the multiplication, then the division, the addition, and the subtraction. So this is actually the rule that we must follow. Say, for example, 3 plus 3 times 4. So which one will come first? Can we see any parentheses? Of course, there is no parentheses. Can we see any exponents? So there is none. Can we see multiplication? Of course, there is. So we're going to have first 3 times 4, and that will give us 12. And the next one is addition. 12 plus 3, or 3 plus 12, that will give us 15. So in this case, the quantity of 3 plus 3 times 4. So in this case, we can now see the parentheses. So that means we're going to do first the operation in the parentheses. So that is 3 plus 3, that gives us, and 6 times 4, that will give us 24. So as you could see, we have here the same numbers, the same operations involved, but only that here in this case, there is parentheses, but the result is very different. So here in this case, what we will do is that we're going to attach names to numbers, because usually we give a certain value to a certain name. So for example, we have here a is equal to 4, and that we will do 5 plus a. So that means a now is carrying the symbol or the value of 4, and that means 5 plus 4, and that becomes 9. So in this case, this naming is actually what we call label. And this label is also called a variable. So when we use that in a certain mathematical expression, and this is actually very common, and this is actually used when we are dealing with algebraic expression. So 6 minus a, that will give us 2, because we have already given here the value of 4 to a. So 6 minus 4, that becomes 2. 6 times a, or 6 times 4, that gives us 24. So in this case now, a, which is 4, raised to the power of 1/2, or we could say that in another way, square root of 4, and that gives us 2. So what about fractions? How do we deal with fractions? The first thing that we're going to do is we're going first to import the modulo fraction for us to be able to do the operations of fraction. From fractions, import fractions, then f. So we have here a certain name, and we attach a value to that. So fraction. Here 1 is the numerator, and 3 is the denominator. So that will give us 1 over 3. So when we execute this code, then we will be given fraction 1 over 3. So having already this function or this value, now we can do some kind of operations like what we have just done. The basic mathematical operations like subtraction, addition, and so on and so forth. So here we have the fraction 1 over 3 plus 2 minus 1 over 6, or 1.6. So remember that here in this case, we need to follow the PEMDAS. So 1 over 3 plus 2, then minus 1.6. So if we're going to execute this, then we will be given 0.73, 3333, and so on and so forth. So also we can do fraction plus another fraction. So when we have 1 over 3 plus 3 over 5, then we will be given 14 over 15. It's a very basic thing about doing mathematical operations using fractions. So this time, we will have complex numbers. So what is a complex number? So for us to be able to properly understand what this complex number is, let's have some definitions of what this one is. So a complex number is the combination of both real numbers and imaginary numbers. So what is an imaginary number? So an imaginary number is the number, when squared, will give us the negative result. It is written in the form of real numbers multiplied by an imaginary unit called I. So for example, we have 5i. This means that this will give us the result of negative 25 because the value I squared is negative 1. Because this is negative 1, this will give us the value of negative 25. Okay, so for example, when it is 7i, then this will give us the value negative 49. Again, it's because the value of I squared is negative 1. So there you go. We already know the definition of a complex number. So let's go back to our work. So here we have a is equal to 1 plus 3j. So this will give us 1 plus 3j. So when we want to know what data type A is, then we could have type A, then we will be given complex. Another thing, or another example is A is equal to complex 1 plus 3. So we will be given 4 plus 0j. Why is this? It's because 1 and 3 here are both real numbers. And because they are real numbers, then we will be given 4, and a complex or an imaginary number is added to 4, and that is 0j because here we have never set any value for an imaginary number. Here, we have b is equal to 1 plus 3j, and when we do the addition, then we have a plus b, then we will be given 5 plus 3j. And why is this? So let's go back to this one. Here, the value of a here is 4 plus 0j, right? So in this case, because we are adding now b to a, then we will be given 5 because 1 plus 4 is 5, and 0 plus 3j is 3j, or 0j plus 3j is 3j, right? So we can also do the division of these labels, okay? So we could have a divided by b, and that will give us this result. We can also use the real and imaginary parts to calculate the magnitude of a complex numbers with a formula where x and y are the real and imaginary parts of the number. So I believe this one is very familiar to you. So we are just getting the square root of x squared plus y squared. So how do we do that? So here, we do the c dot real. We multiply that to 2, which is actually the exponent. And here we are also getting squared value of c dot imag. So let's remember this, that here c is a real number. Let me correct myself. And in the second one, c is an imaginary number. So what do we get if we do that? So this, we will be given 5. And I just would like to make some kind of clarifications. Maybe you would like to ask, where did we get c.real and c.imag? Here, we have actually defined them right here. So c is equal to 4 plus 3j. Then we get the value of the real number. The real number is 4. Then we have here 4.0. And the value of the imaginary number here is 3, right? So that's why we have here this value. So why is this? 4 times 4, that will give us 16. And 3 times 3, that will give us 9. So 9 plus 16, that will give us 25. And because we would want to get the square root of 25, so we use here 0.5, which is equivalent to 1/2. We have here 5. I think that's now very clear. And what about if we want to get the absolute value of something? So what we do here is that we will just use this function, the abs function. So what's the value or absolute value of c? Then this will give us 5.
Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.